Welcome to today's Explainer. We are diving into something literally massive today. We're unpacking a wildly ambitious plan detailed in our source material, all about how Tesla and SpaceX are joining forces to build what they're calling a Terrafab, basically a colossal AI chip factory. Now, the claim here is that this facility will be 50 times more ambitious than anything currently existing on planet Earth. But right out of the gate, I gotta tell you, this plan is facing some incredibly intense pushback from the established heavyweights in the semiconductor industry.
And look, that skepticism, it's coming straight from the top. C.C. Wei, the CEO of TSMC, who is essentially the undisputed titan of the chip manufacturing world, is firmly stating there are no shortcuts. He maps out this rigid, unbending timeline, 2 to 3 years just to build a new fabrication plant, and then another 1 to 2 years just to ramp up the production. He views chip manufacturing as this fundamentally unrushable process. So, to the entrenched industry, the timeline Tesla and SpaceX are aiming for is, well, it's basically impossible.
So, the crucial point is, why try to do the impossible in the first place? It's because of the sheer scale required. According to prominent SpaceX investor Ron Barron, Tesla and SpaceX don't just need a slight bump in supply. To pull off their future plans, they need 50 times as many chips as the entire world currently produces combined. That's a staggering number. And the existing industry? They simply refuse to take on the massive risk of scaling up to that unprecedented level just for a single client.
Okay, let's get into Section 1, the massive chip dilemma. Why are Tesla and SpaceX being forced into this daunting do-it-yourself corner?
It really boils down to incredible inefficiency. Right now, Tesla is buying standard general-purpose chips from companies like NVIDIA. And don't get me wrong, these are amazing chips, but they're built to do a little bit of everything for everyone. In reality, Tesla only utilizes about 6% of the content and capability of those chips for their specific AI needs. Think about that. That leaves 94% of what they are paying for completely unused. When you need chips by the millions, that kind of inefficiency is a massive financial and physical bottleneck.
And when you look at the economics, the dilemma gets even clearer. General-purpose NVIDIA chips come with whopping profit margins, around 80% going right back to NVIDIA. But by designing highly specialized chips that do only the exact 1 or 2 things Tesla actually needs, the source projects a staggering 70 to 90% reduction in costs. They literally have to build this themselves to control their own destiny and, of course, their bottom line.
Moving right along to Section 2, Skeptics versus Tesla's History, or as we're calling it, the Disruptor's Playbook. Let's move to and see how this builds. You know, the semiconductor industry swears this rapid DIY approach can't be done. But years ago, the world didn't make enough electric vehicle batteries for Tesla either. So what happened? Step 1, they partnered up with Panasonic. Step 2, realizing they needed way more, they unveiled their own homegrown 4680 cell and achieved a massive dry cathode breakthrough. And Step 3, continuous in-house production. They actually took inspiration from the continuous manufacturing lines of the glass bottle industry to shoot out batteries at scale. They've faced impossible supply bottlenecks before, and they solved them by bringing the whole operation in-house.
And here's the thing. They don't just figure it out in a lab, they scale it. Even at their current early scale, our source notes that Tesla's battery factories in Texas and Berlin are aiming to produce enough of their own 4680 cells to power up to 1.5 million Cybercabs a year. So they've absolutely proven they can take highly complex proprietary tech and scale it up immensely. Tesla's unboxed production method is a total paradigm shift. They have literally re-engineered the car, which is arguably the world's most complex mass-manufactured consumer product, for a 100% automated manufacturing process. We're talking 0 humans on the line. They are absolute masters of building the machine that builds the machine.
If you want a more recent precedent, just look at what Elon Musk's xAI recently accomplished with their Colossus One supercomputer cluster. Compared to a traditional data center build, which, let's face it, is usually pretty slow at a standard scale, xAI built a massive cluster 3 times bigger than the industry norm. And get this, they did it 20 times faster than the experts thought was even possible. This is exactly why TSMC's timelines don't intimidate them.
All right, Section 3, Building the Foundry Alliance. Let's look at the exact division of labor required to make this Terrafab a reality.
Okay, let's dive into this. Pulling off a Terrafab requires an unprecedented alliance among tech giants. It's not a solo mission. Step 1, Intel is providing the foundational manufacturing process.
Step 2, Samsung brings their specific AI chip and fab expertise to help design those production lines. Step 3, Tesla and xAI act as the ultimate engineering powerhouse, utilizing massive computing for simulations and research. And finally, Step 4, SpaceX steps in to handle the massively scaled-up phase of the facility. It is a staggering collaboration.
So what exactly is Intel bringing to the party? The Intel 14A process. This is a state-of-the-art 1.4 nanometer class semiconductor manufacturing process. Tesla and SpaceX aren't starting from scratch here. They're taking advantage of Intel's aggressive push to regain process leadership in the sub-2 nanometer era, using it as the literal physical foundation of the Terrafab.
But before they build the massive Terrafab, the alliance is starting with a $3 billion research fab right in Texas to test new physics and packaging and to run through thousands of manufacturing iterations. But their real secret weapon? It's their in-house Tesla One AI system. They're going to use this highly advanced AI to simulate millions of chip designs and manufacturing processes, virtually optimizing the entire factory before they even pour a drop of concrete.
Which brings us to Section 4, powering the AI future, the ultimate end goals for these highly specialized chips. And this brilliantly illustrates the sheer scale we are talking about. The source projects that the final Terrafab will be 10 times larger than Giga Texas. To put that into perspective, Giga Texas is already one of the largest buildings by volume on the entire planet. Multiplying that physical footprint by 10 is almost beyond comprehension. It's practically its own zip code. It is a manufacturing flex of truly historic proportions.
So where do all these billions of specialized AI chips actually go? Well, there are three primary world-changing beneficiaries. First up, this localized chip supply will power millions of fully autonomous Cybercabs. Second, they're going to serve as the brains for hundreds of millions of Optimus humanoid robots. And third, they're destined to fuel SpaceX's planned off-world data centers.
And that leads right into the most futuristic and frankly mind-bending claim from our source material. The ultimate vision actually involves manufacturing these specialized chips in the Terrafab, physically launching them into space via railgun, and then assembling them into off-world data centers on the moon or in orbit. These massive AI clusters would then communicate with each other and back to Earth using Starlink's proprietary laser technology. They're literally mapping out the off-planet infrastructure for the entire AI future.
The industry experts are practically shouting that this is impossible. But we've seen this disruptor's playbook totally shred the established rules before. Which leaves us with a massive, provocative question. If it works again, what happens to the global balance of power when one single tech alliance successfully controls its own infinite, vertically integrated AI chip supply? It is a fascinating, wild prospect that could completely redefine the future of our global tech infrastructure. Thank you so much for joining me for this explainer. I hope this breakdown gave you a lot to think about, and definitely keep your eyes on this space.